Today I'm going to take you back to Algebra 2 and review with you some of the trigonometry that you learned. That's really important to have off from the top of your head this year and as you move on through upper level math courses. So this is called Basic Trig Facts that you should have known or you should have learned last year in Algebra 2. Some people have forgotten a little bit of it. First of all the work that you do with trigonometry and upper level math courses is in radians. So you learned trigonometry in degrees at first, and then last year you learned about radians. So what you have to do is you have to know pretty quickly in your head how to convert from degrees into radians for the special angles. So what I'm going to do is I'm going to set up a chart. And this chart is going to list the degrees of the important angles or the special angles that we talk about this year and what those values are in radians. And then what the sine of those angles are going to be and the cosine of those angles. And we get the sine and cosine, and we're not going to talk about tangent yet because we haven't graphed those, but you'll also have to know the tangent values. And you can memorize these values if you want, or you can always refer to, you called it a 30, 60, 90 triangle in geometry when you learned these, but instead of 30, 60, 90, we're going to talk about these triangles, special triangles in radians. So this would normally be 30, 60, 90. 30 degrees is pi over 6, and we'll add this to our chart. 60 degrees is pi over 3. We'll add that one to our chart. And the sides, the proportion of the sides in a 30, 60, 90 triangle are across from the 30 degrees is 1, across the hypotenuse is 2, and across from the 60 degrees is the square root of 3. And if you do SOHCAHTOA, you can get the sine, cosine, and tangent of those two special angles, 30 and 60 degrees, which is pi over 6 and pi over 3 radians. And then the other special triangle that you learned in geometry class was the 45, 45, 90. But instead of 45, 45, 90, we'll call it radians. 45 degrees is pi over 4 radians. So it's pi over 4, pi over 4. 90 degrees is pi over 2, but the proportion of those sides are the two legs are both 1, or they're both the same, and the hypotenuse is the square root of 2, or if these were each 2, that would be 2 times the square root of 2. So those are the proportions of the sides. We can do 30, 60, 90, 45, 45, 90 SOHCAHTOA. So in degrees, if you have a 0 degree angle, of course it's 0 radians, and the sine of 0 degrees is 0, but the cosine of 0 is 1. I think we know that from our graph. The next important angle, I'll call it 180 degrees. 180 degrees is important because that's pi radians, and the other special angles can come from pi. The sine of pi radians is 0, and the cosine of pi radians is -1. Again, you can get that off from the graph, the cosine. Now we'll start talking about the special angles in between 0 and 180. We'll talk about the 30 degree angle, the 45 degree angle from the other triangle, the 60 degree angle, and then the 90 degree angle. And then we'll talk about other quadrants. Besides, these are quadrant 1. 30, 45, and 60 are quadrant 1 angles. 30 degrees is pi over 6 radians. That's because 30 over 180 is 1/6. 45, and the sine of a 30 degree angle from SOHCAHTOA from over here, sine of 30 degrees is 1/2. You need to know that off the top of your head. The cosine of 30 degrees is the square root of 3 over 2. And if we were to graph that, that's approximately equal to 0.87. Just so you know on a graph where to put that, square root of 3 over 2. 45 degrees, 45 over 180 is 1/4. So in radians, it's pi over 4. And the sine, this is with a rationalized denominator. You could call it 1 over the square root of 2 if you wanted to. That doesn't bother me. But in most textbooks, you'll see it written as the square root of 2 over 2 with a rationalized denominator. And the square root of 2 is approximately equal to 0.7. And the sine and the cosine of 45 are both equal. So it's about 0.7. 60 degrees, 60 over 180 is a third. So in radians, this is pi over 3. And you just reverse the sine and cosine from 30 and 60 degrees. So the sine of 60 is the same thing as the cosine of 30, which is the square root of 3 over 2, which is about 0.87. And the cosine of 60 degrees is a half. And then 90 degrees is pi over 2 because 90 over 180 is a half. The sine of 90 is 1. The cosine of 90 is 0. And those are the important angles that you have to know. If you get into other quadrants, a 30-degree angle, a 30-degree reference angle in quadrant 2, for example, you would use these same sine and cosine values, but you'd have to consider the sign, whether it's negative or positive, with all students take chemistry, or whatever funny saying your Algebra 2 teacher used for you to remember ASTC. But you have to remember the sine is positive in quadrant 2, tangent is positive in quadrant 3, and cosine is positive in quadrant 4. And then one other thing basic that you should remember from Algebra 2 is the unit circle. It's called a unit circle because the radius is 1 unit, or 1. So a unit circle has coordinates of 1, 0, 0, 1, negative 1, 0. This is a horrible circle, sorry. And 0, negative 1. So 1 unit means the length of 1 for the radius. On this unit circle, there are an infinite number of points. And if I just choose one point, maybe I'll choose this one point up here on the unit circle, call it xy. And if I create an angle here at the origin with the x-axis, we'll call that angle theta. Then the x value of this coordinate is equal to the sine of whatever that angle is that I've rotated around. Sorry, I always do that. It's alphabetical. X is equal to the cosine of theta. And the y value is equal to the sine of theta. And I remember these alphabetically. X comes before y, C comes before S, alphabetically. So for example, if this theta value was pi over 6, if I rotated this around pi over 6 radians, then this particular point xy is equal to the cosine of pi over 6, which is the square root of 3 over 2, followed by the sine of pi over 6, which is a half. And if I went around into the other quadrants, then I would have to consider all students taking chemistry to figure out whether the x or the y goes negative or positive. So those are some basic trig facts. You might want to make some flashcards for yourself with some index cards, because when I say pi over 6 radians, if I say, what's the sine of pi over 6? It shouldn't take you very long to say, oh, the sine of pi over 6 is a half, or the cosine of pi over 3 is a half. And then when we get into other quadrants, I'll say, well, what is the sine of 210 degrees? And so then you'll have to figure out some reference angle, and then whether or not the sine or cosine goes negative, and then the value from these columns. So this example of this sketching the sum of two functions, we're going to sketch the sum of two functions with different periods, two trig functions. First of all, we'll give you the example. Let's do y equals 2 cosine of a half x minus the cosine of 2x. All right, we have the period here being 4 pi, and the period here equals pi. And I'll ask you to sketch in the domain between 0 and 4 pi. So we have to have our our x-axis. I think I'll use a ruler since this is going to be so long. It's going to be a long x-axis. We'll go to 4 pi here. And halfway is 2 pi, and halfway is pi, and halfway is 3 pi. So we'll sketch 2 cosine of a half x first. So go up to 2 and down to -2. I'll sketch that out, see what that looks like in red. So it starts out, cosine starts out at the top, middle, bottom, middle, top. So cosine curves are concave down, then concave up, then concave up, and concave down. So we're going to add this function to the negative cosine of 2x. I think I'll do that in green. Well, this period is pi, so we have to have one full cycle between 0 and pi. So in this function, we're going to have 4 cosine curves, and it's going to be one in each one of these segments. So each one of these segments I'm going to divide into 4. So I divide in half, and then in half again. And the negative cosine of 2x has an amplitude of 1, but it starts at the bottom. So we got bottom, middle, top, middle, bottom. Concave up, concave down, concave down, concave up. So there's one. We're going to be adding these two green and red together. So I'm going to go ahead and I'm going to divide the next 3 segments into 4. So divide it in half again, and sketch our next cosine curve. So we've got bottom, middle, top, middle, bottom. So we've got concave up, concave down, concave down, concave up. Again, divide, 0, max, 0, min, concave up, concave down, concave down, concave up, and then one more cycle, middle, top, middle, bottom. So how are we going to add these? Each one of these tick marks is pi over 4 because pi has been divided up into 4 equal segments. So you've got pi over 4, pi over 2, 3 pi over 4, and pi, and we can continue to count that way if we want to. But what I want you to do is for the sum of those two functions, for the green and red combined, what I would like you to plot, you must plot points where either function has a 0 and a 0 is an x-intercept, as you know, or where we can specifically calculate an exact value or an approximate value. Either approximately or exactly. And what do I mean by that? What I'm going to do is I'm going to run through both of these functions, and I'm going to add the two y values together, and that's going to give us our sum. Instead of setting up a long chart with each one of these tick marks on there, that would be a very long chart. I'm going to just add the y's together. So right here we have -1 plus 2 is +1. So this is our final graph in black that I'm going to do our graph of this. So adding those two y's gives us this. Now right here, this green graph, this is a 0. So 0 plus the red will be right on the red. So there's our specific point right there. Anytime we hit a 0 of the function, the final curve will be on the other function. So here's a 0 right here. So our final curve, the one I'm going to do in black, will have a point right there. Here's another 0 of the function. It'll be right on that red curve. Here's another 0. It'll be on that curve. Here's another 0 on that curve. So wherever the green hits the x-axis, our final point will be on that curve. And it works the other way. Wherever the red has an x-intercept, our final curve is going to be on the other one. So here is an x-intercept, so our final curve is going to be here. Here's another x-intercept, so our final curve is going to be here. So I've got a whole bunch of points right here that I can put together. And the only other thing I'm going to do now is see if I can, for these other tick marks, if I can approximate where that curve is going to go. So this green value right here, this y value is 1. This is a little bit above 1. So if I add 1 to this red, it's going to be up here. Those two y values added together will be somewhere up in here. So what I have is I have a curve that's coming around like this. And then here's my other specific point. So I'm going to be coming down like this. I've got to go through the x-axis between here and here. So I think I'll be coming down around like this. Now those two together, those two negatives together, will probably be dropped down in here, but I'm really not too sure. So I'm just going to come and connect this here. Now this is 1. And if I add 1 to this value, which is not quite -2, I should get something that's not quite -1. So I should be up in this area right here if I add 1 to this y value here. Then I'm going to be coming down. Oh, here's another specific point I can calculate. This y value is -1. This y value is -2. When you add them together, you're going to get -3. So my curve is going to bottom out down here at -3, come up through here. And again, I've got the same situation. If I take this red curve and add 1 to it, I'll probably be up in this area. So I'm going to come around here, going to come up through the x-axis. And right here, I've got another situation where I take this red curve, add 1 to it. So I'll be up in this area up here. And here is our final curve. So you might want to rewind this video and just take a look at it one more time again to see how we're going to calculate each one of these y values. Sometimes we can calculate them exactly, like in this point right here, -1 plus 2 is equal to 1. We can calculate that exactly. This one is exactly. This one is approximate, but I have a pretty good idea where it is. This one is exact. So you can go through each one of these and then try to pick this out. So you've got a pretty good idea what this curve is. And now what I suggest is that you take your graphing calculator and put this in and have your x min be 0 and your x max be 4 pi. And you can have your y min be -3 because that's our lowest point. And then the y max, you can set your y max to 3 because it comes above 2. It might come up to 3. And that's it for today.